Yes, thank you, Darshana. Thank you, Gopalji. To the initial discussion, Gopalji, what we were discussing about the immersion cooling. All right, okay. I was recalling one Moore's law as an industry expert. We have been working on that. Moore's law is kind of a very fundamental law for us as we move into this electronic revolution of this industry. The Moore's law says that there is going to always the transistor, the microchip are going to double in every 2 years. And as we move forward, the the compactness of racks are going to be there. It is going to be more and more complex. And as we move forward, like we expect, like liquid cooling is going to be beneficial. It also comes with a flip side of it that it is going to be more technically complicated design where you will be having a liquid based cooling coming through that hardware, and there will be always a space constraint to have a liquid passing through those lines and then absorbing heat and then keeping those racks cool. I think this is going to be a challenge for every other industry professional who is trying to get into liquid based cooling. So to have that, just to counter that and kind of the setup we have in India, right? We see that we still have a air cooled system as the best alternative right now. Because if I just compare with a tier four kind of a design, imagine what kind of a capex investment it may call for heavily complex design to go for a liquid based cooling. This is going to be very economically very challenging for all investors, and this is going to be one of the things which is going to be needs to be addressed as we move forward. So yeah, this is the best technical solution right now, but may not be economically viable if we talk about tier four kind of a data center. So just if you look at overall India as a market, India as a unit, here we have available options are more related to air-cooled based cooling technology. And I think more or less we have a lot of solutions around. Apart from having this liquid-based cooling, there are alternatives where we have some options which are related to thermocycle-based split systems, which are waterless technology. So those are also kind of a technology available out there, but we are right now operating in US and slowly expanding to Europe. That technology may come in India in some years, but it is going to take time. But right now, what system what we have where air cooled chillers are the part of a data center cooling system, we have a very much relevant solution around this, and I think that this is the right forum where we can discuss about it. Like evaporative cooling, I have just shared my views around. But what happens is I assume everyone is not aware about what PUE is, and maybe we may have to little bit just check what PUE really means and then what are the data center core needs. So let me just spend a couple of minutes on this. So I assume all our audience may not be aware about the technical jargon for PUE. Let me simplify it a little bit and then take this forward. So what is our data center core needs? If we look at the today's core priority, what our data center customers want is that they want to maintain their baseline services. And for that, as Vaibhav rightly said, we need to have a maximized uptime and availability and maintain physical and fabric security. I think we have let's based on that. My speed of the speed to market. So this market is evolving so rapidly, we need to catch the pace. I think that is what the core needs right now. But along with that, there is also important thing is how to keep a cost control on this, because it does not only talk about the capital investment, but at the same time, it is going to be operating cost. So optimized capex is something we will always talk about because we have a lot of investment coming in. So we will normally look at that, how we should optimize the capex. But then today, I just want to request your attention on how we can improve on the operating expenses and its efficiency, so that we move forward in some kind of idea that what are the best alternative at the cheapest cost available, and then how can we implement that. All right. So let me just simplify this whole PUE kind of thing. If I just take to that, what PUE is that? Like for research effectiveness, we normally talk about this is just the total facility power divided by total IT power. All right. So what we normally talk about PUE is nothing but what comprises of total facility power and what is your IT power. So when we talk about the power usage, the distribution part of it, normally we have seen that the rack part of it, which is a critical load, which is going to be around 75% of the power consumption. Okay. 75% is the use because this is related to that. But the next big thing with this setup is this cooling system where, air-cooled chiller right now are around 13 to 14% of the power consumption. And that's where precisely where we normally come forward and come discuss that. How can we have this air-cooled chiller efficiency going up now? What happens is that OEMs, like Sujit will agree with me, that we normally go with a lot of electronic gradation, like having the VFDs on it, or maybe we talk about like having efficiency on the part load side and overall condenser optimization, condenser fans optimization. A lot of things are done. But a very simple thing which normally we see that is missed out of is that there is a basic thing called a refrigerant lift. Now, when we call refrigerant lift, that amount of work done required by a compressor to achieve the certain capacity, that depends on what is your condenser entering temperature, condenser entering air temperature. And eventually, there are certain basic available methods, which is called evaporative cooling for the condenser coil, that helps to reduce your condenser coil temperature by not less than 12 to 13 degrees centigrade. Imagine you have a 40 degrees centigrade and you have a reduction in the temperature by around 12 degrees centigrade, coming at 28 degrees centigrade, and having a pre-cooling heat exchangers along with it. Just imagine like kind of efficiency recovery can be done. You may not even need to operate chiller in some cases. But those technologies are available and very reasonable cost, and we have to just incorporate. Yeah, now we talk about, like Shailesh mentioned, about water usage effectiveness. It will also be part of it, and it is going to consume water. But then there are alternatives to it where, water consumption can be monitored. Water consumption can be, taken care of, and then we have minimum water consumption to make sure that water is being used with a very thoughtful process, and then we achieve the desired heat rejection, and then improve on the overall power usage effectiveness. So these are very basic elements to it. Normally, what happens, we talk about white spaces, we talk about how we can reduce the cost on the operating side, on the rack side. But it is a very simple thing and small thing which is going to be helpful for that. Now, what happens, like also they mentioned about one thing, that normally in a data center, there are a lot of chillers kept on the terrace level, or maybe in a one area where 20 chillers are put together. What happens is that normally we can correlate it with the concept called heat island effect. What heat island effect is that because of no ventilation around, or maybe amount of air which gets processed through the chiller, the amount of heat is dissipated from the chiller, and no natural ventilation is formed, the air came to a short cycle, because the hot air again comes back to condenser entry. And basically what happens, because of that hot air coming, the refrigerant lift goes up, compressor work done requires to be higher side, which means that your power consumption is naturally going to go up. Now, theoretically, when we are designing a system, we may not consider that this can be a practical challenge which will be coming across. But in a real life, it happens. Like number of chillers when you are put together at one location, you are going to have a short cycling. Your chiller is going to trip on high oil temperature or high pressure. This is a challenge where this kind of a very simple method, very technically proven method, can help to reduce this operating pressure, relaxes the operating pressure from the compressor side, and put down the compressor power consumption. So that's precisely where it can give you effect, and efficiency is improved on that. Also, because of the higher condenser pressure, normally your chiller lifespan goes down, wherein in the evaporative equipment, that gives you advantage that your life cycle of the chiller, life span of the chiller goes up. Maybe we have seen this, pH diagram where, we have seen how the compressor takes refrigerant at the suction side, goes to the point 2, where total work done by compressor is demonstrated on a pH cycle. That goes down because condenser entering goes down. So around 20 to 25% saving is assured on that, provided like we just do a small correction. My request here to all audience that maybe we focus a lot onto a white space design and improving the efficiency there, but then there are certain small corrections are available which can be done, and we can improve on efficiency side.
Thank you, Mr. Umesh, for sharing ways to improve PUE through evaporative cooling on air-cooled chiller. We request our delegates and viewers to stay connected with us on our social media handles. Thermal Control Magazine is available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. With this, we want to announce the closing of today's session. Request you to stay tuned for more such sessions. Thank you and goodbye.